Hello viewers, in today's lesson we will be discussing about normal distribution, which is part of the special probability distribution. In the last lesson we were able to cover two of the special probability distribution, which include binomial distribution and Poisson distribution. In this lesson we will move into the last special probability distribution, which is normal distribution. If you are new to this channel, kindly make sure you subscribe and like and share the video with your colleagues that are also going to find it helpful. Without wasting much of our time, let's move into what we have in this lesson: normal distribution. Normal distribution. So, normal distribution is also a special type of probability distribution which follows the normal statistical table. The normal statistical table is the one guiding the normal distribution. And one thing about the normal statistical table is that it is symmetrical in nature. So, as we move on, we're going to be applying the idea of symmetry in some of our normal distribution. So, I also want us to take note of some of the rules in normal distribution, which are going to help us as we move on. So, the fact that our normal distribution is symmetrical, what am I saying in essence? What I'm saying in essence is this. This is our normal distribution. This is our normal distribution. This is the line of symmetry. The line of symmetry makes it symmetrical. What is trying to tell you that what you have in the negative part will be equal to what you have in the positive part. This gives you the negative part. This gives you the negative part. And this gives you the what? The positive part. This gives you the positive part. That is, here we have 0. We have 0 here. So, for example, let's say we have minus 0.5 around here. Let's say we have minus 0.5 around here. Automatically, we have 0.5 here. So, the distribution of minus 0.5 to this side will be the same as the distribution of 0.5 to this other side. So that is why the normal distribution is symmetrical in nature. Normal distribution is symmetrical in nature. Please take note of that. So what are the rules we are going to be applying when we are solving problems under normal distribution? As I have told us, normal distribution, the only thing guiding it is your normal statistical table. So you're going to, any problem you want to solve under normal distribution, you're going to be making use of a particular table, which is your normal distribution table. So you can find that online, or you can get or buy an hard copy. If that will be more easier for you. For the exam situations, you might be provided with the statistical table, or you might be asked to bring it along. But to be on the safer side, it is advisable to print a copy and take it to the exam center. So what are the rules in normal distribution? The first one says the probability of x less than, let's say, the probability of z less than a. The probability of z less than a is equals to 5a. The probability of z less than a is equals to 5a. The second one, and also I want you to take note that this normal distribution table is also known as the Z table. So that is the variable or the unknown which we use to denote the values we are going to calculate in the normal distribution table is known as the z. Is known as what? Is denoted as z. Your a is just any value. It can be any value, any value you are given. That's why we just represent that a as we just use the value to represent an arbitrary variable a. So the second rule says the probability of z greater than a. The probability, this one is less than, while this one is what? Is greater than. And likewise your binomial and your Poisson distribution, when you have this greater than, it is not variable. So you need to convert the greater than to less than. And how do you convert your greater than to less than? You simply subtract the less than. You subtract by 1. While if it is in a binomial and Poisson distribution, you look for the number immediately less than that number. Then you subtract 1 minus that immediate number. But in this situation, you are still subtracting the same number, that is a. That will be 1 minus 5a. 1 minus 5a. So what 5 means is just the value in your statistical table. Just go and check the value of z under your statistical table. So the next rule says if you have z less than minus a, this is also less than, but we have a negative here, minus a. So that negative is not desirable because you cannot even check for negative value in your statistical table. It doesn't have negatives. Though there are some statistical tables that are having for negatives, but the most common one doesn't have for negative. So definitely you will be needing to convert negative to positive, which is also equals to 1 minus 5a, which is also equals to 1 minus 5a. It is as the same as z greater than a. So the fourth rule says if you are having the probability of z, or let's say the probability, if you are having the probability of x1 less than x less than x2 less than x2. So it is definitely going to be the probability of z1 less than z less than z2 which can be broken down simply into 5 z2 minus 5 z1 minus 5 z1. What x means? X is the actual values you're going to be given. Your first job is to convert your x to z. So after converting your x to z, then you will finally compute your phi. You finally compute your phi. So that is that about the rules in normal distribution. And now, how do we know the kind of question we are going to be using normal distribution to solve? How do you know the kind of question we are going to be using normal distribution to solve? The first thing I want you to take note that in any question involving normal distribution, you will not be given probability of success or probability of failure, like the situation of binomial and Poisson distribution. Here we are not having those parameters. When you are not having those parameters, definitely you know you cannot use binomial or Poisson. The parameters you're going to be given in normal distribution, in question requiring normal distribution, include your mean and your standard deviation. Your mean and your standard deviation. And what's the work of your mean and your standard deviation? The work of your mean and your standard deviation is to convert z, to convert x to z. We said the first thing is to convert x to z before you now check the value from your probability from your normal distribution thing. Then how do we convert our x to z? You definitely make use of the formula. Which says z1, or let's say z equals to x minus mu over sigma. So if you have z1, your z1 will be what? x1 minus mu over sigma, and your z2 will be what? x2 minus mu over sigma. It is still the same mu, that is the same mu and the same standard deviation. Standard deviation is sigma, while your mu is what? Is mu. So without wasting much of our time, let's solve an example on normal distribution. So this question says a random variable x whose distribution is approximately normal has a mean 81. I already told us that in any question involving normal distribution you will be given mean and standard deviation. Those are the two parameters that are going to be given. So the question says mean equals what? Mean equals 81 and a standard deviation of 6. Standard deviation equals what? Equals 6. First off, find the probability that the variable lies between 78 and 85. It lies between 78 and 85. Automatically, you are being asked to find the probability of what? Of 78 less than x less than 85. You will be given to find the probability of x. The probability will be involving x. But it is your work to convert it to what? To convert it to z. So this is the probability we have to find, because we have to find the probability that it lies between these two values. So without wasting much of our time, let's solve solution. So the first thing you need to convert, here you are having x1 and x2. Your x1 is equals to what? 78, while your x2 is equals to what? 85. So you convert x1 to z1 and convert x2 to what? To z2. So converting your x1 to z1, you have what? z1 to be equals to what? x1 minus mu over what? Over sigma, which is equals to what? Which is equals to 78 minus mu minus, that's minus what? That's minus 81. That's minus 81 over sigma over 6. Over 6. And if you do that very well, you should be having minus 0.5. Minus 0.5. So z1 is equal to minus 0.5. So we also calculate for z2. So z2 is equal to x2 minus mu over what? Over sigma. x2 minus mu over sigma. So our x2 is what? Our x2 is 85 minus mu. Our mu is 81 over standard deviation to 6, and we are going to having 0.667. So we have been able to determine our z1 and our z2. So we can now write our probability as the probability of z1 less than z, less than what? Less than z2. Which is equal to the probability of what's our z2, our z1 is minus 0.5 less than z, less than probably less than z2, which is what? 0.667, which is equal to 0.667, which is equal to 0.667. see from this problem, you have a negative here, and from our formula, which is involving z1 and z2, where we said z1 and z2 should be what? Should be 5z2 minus 5z1. That one does not have negative. So what do you do with this negative sign? You manipulate it or transform it into what? Into positive. Then how do you transform that into positive? Then you should be able to break this down into two sets of probabilities. And what are the two sets of probabilities? You can say let this be the probability of minus 0.5 less than z less than 0, you know, from minus 0.5 to 0, plus the probability of what? Of 0 less than z less than 0.667. We have been able to break this down into two probabilities, but we are still having negative sign here, so we still need to transform that negative sign to what? To positive sign. But remember that I told us that our normal distribution table is what? Is symmetrical. That's anything you're having from negative to 0 is equals to what? Anything you're having from what? 0 to what? To positive. So anything you are going to be having from minus 0.5 to 0 will be the same as anything you are going to have for what? From 0 to 0.5. From 0 to 0.5. So automatically you can say this can be transformed into what? Into probability of 0 less than z less than 0.5 plus the probability of 0 less than z less than 0.667 less than 0.667. So we have successfully transformed our negative to what? To positive. Then we are good to go. We can now make it of what? 5z2 minus 5z1 in this what? In this situation. So automatically, what do we have? We are going to be having what? 0.5 minus 50 minus 50 plus 0.667 minus 50 minus 50. So the next thing is now to check our values of 5 from our normal distribution table. So some of us might be having difficulty in checking the normal distribution table. So the normal distribution table is going to be displayed on the screen. So you can check. I might be explaining some little things on how to check for normal distribution. For values on the normal distribution table. So the first thing you want to find the normal distribution for what? For 0.5. For 0.5, as you are seeing from the normal distribution table, how do you check for 0.5? You simply need to check the first thing you need to check on normal distribution table is the first column under Z. The first column under Z. The first column under Z is what? Check 0.5 under the first column under Z. The first column which is under Z, check for 0.5, and you check for 0.5. What we are having here is 0.50. So the value after checking for 0.5 on the first column, then go to the first row which aligns with Z and go and check 0.00 under that row, in that row. So you find out, so the point of coincision between 0.5 and 0.000, that will be your value for 0.5. That will be your value for 0.5. And if you check very well from that table, our 0.5 should give us 0.69 When you are less busy, you can also practice with the statistical table. You can check to understand how to check correctly your normal distribution table. Minus, don't forget to have your phi zero, and as you can see from the statistical table, your phi zero is the first, your zero is the first number in the statistical table. Just take 0.0 under 0.000, and that will give you what? That will give you 0.5 minus 0.5 minus 0.500 minus 0.500 plus 0.667. Just as we check for 0.5, we also check for what? 0.67. Under the first column, go under 0.6. After going under 0.6, then you check your header, that is the first row that aligns with Z. Check for 0.067 or 0.06. If you can't find 0.067, check for 0.06. So the point of coincision between 0.6 and 0.00 and 0.067 will give you your value of 0.667. And if you check that very well, you should be having 0.7477 minus 50. We already know that our 50 is 0.500. So you add this up together using your calculator, you're getting your final answer as 0.4392. 0.4392, and that's the answer to that. It is as simple as that. So at this point, I really don't want to be having problem in checking the normal distribution table, because I might not be moving to explaining that in the subsequent examples. Example 2. Example 2. This example says tests on electric lamps manufactured by a company indicated their lifespan could be assumed to be normally distributed about a mean of 1,750. The mean is said to be what? 1,750. 1,750 hours. 1,750 hours with a standard deviation of 70 hours. The standard deviation of 70, that's sigma hours. Full stop. Calculate the probability that an electric lamp or change will burn out in more than 1,000 hours, in more than 2,000 hours, between 1,600 and 1,900 hours. Between 1,600 and 1,900 hours. Solution. Solution. So as you can see, we have been giving our standard deviation. So the first problem says we should find probability that in more than 2,000 hours, that's automatically greater than 2,000 hours. More than, they said it must be more than it must not be less than, it must not be equal to, so it must be more than 2,000 hours. That's the probability of what? Of x greater than what? 2,000, x greater than 2,000. So the first thing we need to do is to transform our x into what? Into transforming our x1 into what? Into z. Into z. So we have x1 to be equals to what? We have z1 rather to be equals to x1 minus mu over what? Over sigma. And here we have what? 2000. x1 is 2000 minus our mu 1750 over what? Over 70. Over 70. And if you do that very well, you should be having 3.571. 3.571. So that's our z1. So automatically our probability becomes what? Z greater than 3.571. 3.571. One thing is also left. We have greater than, which is not desirable. So we need to convert the greater than to what? To less than. And how do we do about that? It's going to form our rules. It's going to become 1 minus 5a. 1 minus 5a. 1 minus 5a. So that automatically is 1 minus 5, 3.571. 3.571. So we can check from the statistical table. I won't be teaching us how to do that again. I've taught us in the first example. So from the statistical table, we can check from the statistical table that 3.571 is going to be giving us 0.9998. 0.9998. So if you complete this very well, you should be having our final answer to what? 0.0002. 0.0002. So that's the answer to this. That's the answer to this. So we're having two questions. The second question. The second question. Second question, second question says, find the probability that it is between 1,600 and 1,900. Probability that is between 1,600 less than 1,900. So what we also need to do here is we need to transform our x into what? Into z. So automatically our z1, which is equal to x1 minus mu over what? Over sigma is going to be what? 1,600 minus our mu, which is what? 1,750 over standard deviation, which is what? Which is 70. Which is 70. So if you do that very well, you should be having minus 2.143. Minus 2.143. Similarly, Z2, what do we have? We have X2 minus mu over what? Over sigma. And X2 is giving us what? X2 is what? 1,900 minus mu. Our mu, which is 1,750 over what? Over 70. Over 70. And if you do that very well, we should also be getting 2.143. We also be getting 2.143. So we are able to get our Z1 and our Z2. So we can write our probability as what? As minus 2.143 less than 2.143. 2.143. So we should have used it directly, that is 5 z2 minus 5 z1, but we have a negative here, which is not desirable. So we need to break the probability down into several probabilities so as to eliminate the negative sign. So we can say this is the probability of minus 2.143 less than 0, less than z, plus the probability of 0 less than z less than 2.143, less than 2.143. You know, if you match this together, it becomes this back. So using the idea of symmetry, I already told us that our normal distribution table is symmetrical. It's symmetrical. That means anything you're having from negative to 0 will be the same as anything you're having from what 0 to positive. So your minus 2.143 to 0 will be the same as 0 to 2.143. So automatically this is the probability of what? Of 0 less than z less than 2.143 plus the probability of 0 less than z less than 2.143 less than 2.143. So having eventually having this to be repeating itself there. So we can easily convert this to what? To 5. So we have what? We have 2.143 from one of our rules, which happens to be the last rule. 5 this minus 5 this minus 5 minus 5 0 minus 5 0 plus 5 this minus 5 2.143 minus 5 0 minus 5 0. So we can check 2.143 from our normal distribution table. We should have been able to do that now. So our 2.143, the ruler very well should be giving us what? Should be giving us 0.9839 minus 50, what are 50? 0.5000, you can put it in 4 decimal places, plus 2.143 again, which is 0.9839 minus 0.500500. So if you do this very well, we should be having 0.96. We should be having 0.9678. Should be having 0.9678 as our final answer. And that will bring us to the end of normal distribution. Now we're going to give us to the end of normal distribution, which is the last special probability distribution. In the next lesson, we will move into some other important aspects of probability distribution. If you are new to this channel, make sure you subscribe, like, and share the videos to your colleagues that are going to find it helpful. Tutor Bosun is here. Thank you.